This next example is to do more resolving forces. So we've got three forces on the diagram here, and we're told that the particle in the middle is in equilibrium, and from there we need to calculate the magnitude of P. So what we want to do is resolve in two directions. So we're going to resolve horizontally and we're going to resolve vertically. And the idea is that because it's in equilibrium, the resultant of the forces needs to be equal to zero. There's no overall force that's going to cause the particle to accelerate. So if we start by getting the components of the forces, vertical and horizontal, and then we'll go from there. So the force P, we've got the angle theta here. This side's the opposite, so that means it's P sine theta here. We've got a horizontal component for P is going to be P cos theta, so very generalised. For the 100 Newton force, we've got this bit is adjacent to 30, so it's 100 cos 30, and then this one's 100 sine 30. We've also got the 140 Newton force, so we have 140 cos 45 because that's adjacent to the 45. This is opposite the 45, so it's 140 sine 45. Okay, so if we resolve in two different directions, so we're going to resolve horizontally first of all. So that means we've got the 100 cos 30 is horizontal, P cos theta is horizontal, and then 140 cos 45 is also horizontal, albeit going the opposite way, so we'll be subtracting that one. Okay, so we're going to have P cos theta plus 100 cos 30 subtract 140 cos 45 because it's going the wrong way, and that will need to be equal to 0. If I calculate the bit that's the 100 cos 30 take 140 cos 45, I get minus 12.392408899 equal to 0. So in other words, P cos theta is equal to 12.392408899. It might seem like I'm giving a lot of decimal places there, but I'm doing that deliberately because I don't want to round anything and then lose my accuracy later on. So we're going to do something similar by resolving vertically. So if we look at the forces we're going to have 140 sine 45, 100 sine 30, and then subtract P sine theta because that's the component that's pulling downwards. So we've got 140 sine 45 plus 100 sine 30 subtract P sine theta is equal to 0. And then just calculating this bit of it is 148.9949494 subtract P sine theta equals 0, and so therefore P sine theta is equal to 148.9949494. Okay, so we've really got simultaneous equations. We've got this bit here, and we've got what we've just written down there. So it's simultaneous because we've got P and theta are both unknowns. Well, to find out what P is from this, the best thing to do is by using a trig identity. So this is quite similar to with parametric equations when you're trying to get an equation for y and x, and you've got trig in there. It's also quite similar to the R alpha method when you're finding R. So if we square both of those things, so P cos theta squared plus P sine theta squared, so squaring both the numbers we had here as well, then the idea is that we're going to be able to use the cos squared and sine squared is one identity. So if I just calculate that right hand side first, so I get 22,353.06674, and so this is the same as P squared cos squared theta plus P squared sine squared theta, which is really P squared times by cos squared theta plus sine squared theta, and cos squared sine squared of course is 1, so P squared is what I've got on the right, and so all I need to do is square root that to find P. And so once we calculate that, we just get P to be 149.5 newtons.